Hi viewers, welcome to another solution. Today we are going to see about what is subsynchronous resonance in the transmission line system and how to reduce that subsynchronous resonance by using PV STATCOM. Okay, so here you see that this is a Simulink model for creating subsynchronous resonance in the transmission line. That means that subsynchronous resonance will be happen when we are using series compensation device, that means series capacitor. So when we are going to use this kind of series capacitor in the transmission line, then that subsynchronous resonance happen. But why we are using this series capacitor in transmission line? So that is having some advantages. That means it improve the power transfer capability. Okay, for example, the long transmission line having high inductive reactance. Okay, so in order to reduce that reactance effect, right, inductive reactance effect, we are adding the series capacitor. So by adding series capacitor, what happen? It reduce the impedance. Okay, so if it reduce the impedance means we can increase the power transfer capability of the transmission line. So for that purpose only we are going for a series capacitor compensation. So if that reactance is reduced, right, then we can enhance the voltage profile of the transmission line under heavy loading conditions. So because of that series capacitor compensation, we can avoid that voltage collapse during big demand hours. Okay, and also it can be used for improve load sharing and economic dispatch. Okay, so and they efficiently share the power with the different power generation source. So for that purpose we go with that series compensation. But the problem in the series compensation is subsynchronous resonance. That means if the transmission line having that steam turbine, okay, uh, low pressure turbine and a high pressure turbine, okay, that are operated below that 50-60 Hz, okay, then it will be create that resonance. Okay, so this is a big problem in the series capacitor. So how we can avoid that series, that is subsynchronous resonance in that system, right, by using thyristor control series capacitor, or else you can go with the power system stabilizer or SSR damping controller. So in this video, how we are going to eliminate that subsynchronous problem by means of a STATCOM, PV STATCOM, we are going to explain here. So here you see that this is a simulation model. So this model having 500 kilovolt transmission line with 3333 megawatt source, and then here we are using series compensator capacitor, and these are the transmission line. And here we are for creating the synchronous subsynchronous action, right, here we are activating some fault in the system for the one cycle, and then after that we have to remove that fault. So how the system will be behave during that before fault and after fault. Okay, and how the that it will be affect the that speed difference, speed deviation in the turbine and torque transmission in the turbine. Okay, so it going to be connected to the generator, and then it has steam turbine with the governor. Okay, so the steam turbine having low pressure and high pressure turbines. Okay, so this is multi-mass spring model. Okay, so here we are creating that fault. So how the system will be behave, so we will check that one. Just you want to simulate this model. So at the time of 1 second we are creating the fault in the system. After 1 cycle, right, we are remove that fault, and then we have to check the response. That means we are checking that generator speed, turbine speed, okay, low pressure turbine and high pressure turbine speed deviation we are checking. Okay, and also we are checking the torque transmitted to the network, right. electrical network we are measuring. So here you see that, right? So because of that fault, right? So that the speed deviation will be keep on increasing. That means this is because of the subsynchronous resonance. That means uh, that frequency that in the electrical network, right? So it going to match with that some natural frequency of this turbine governed model. So that way it will be create the high amplitude, right? In the that means it will be create the oscillation in the steam turbine system. Okay, so that's why this oscillation is creating this because of this subsynchronous resonance of the series compensated capacitor. Okay, so here how we are going to mitigate this problem, how to reduce that subsynchronous resonance. So by using PV STATCOM. Okay, so here I'm going to, so we wait for the simulation completion, then only you can see that variation. Here you can see that, so that the system, that speed deviation as well as torque transmitted is keep on increasing, the amplitude is keep on increasing. Okay, so it will be create some problem, right? Mechanical failure in this shaft, right? That kind of problem will be created in the steam turbine model. Okay, so we must reduce that oscillation, so resonance, right, by using some protective element. Okay, so this is a result without any PV STATCOM. Okay, now we are going to use the system with the PV STATCOM. So here you see that, so here the same system. Okay, so here we are going to install that STATCOM. Okay, PV powered STATCOM. So here we are using PV. PV is almost 100 megawatt, so 100 megawatt. So that going to be connected to the STATCOM inverter. Okay, the STATCOM inverter going to be controlled by means of STATCOM controller. So we need to measure the voltage and current in this point, and then you have to measure the DC line voltage. Okay, so inside that controller, right, we are using the calculation. That means we are applying that MPPT for PV. Okay, and then here we are applying that damping control, and then here we are using DC balance, DC voltage regulator, and then here we are using AC voltage regulator and current regulator, AC current regulator. Okay, so these are control inside the STATCOM. So here we are using that STATCOM to minimize that, that means you have to reduce that subsynchronous resonance in the system, because already we see that, right, when without STATCOM, right, so when fault is initiated, right, and then a fault is removed, right, then what happened, right, the steam turbine speed deviation and then torque transmission, right, it will be that amplitude is keep on increasing because of that subsynchronous resonance, because of that. Okay, so we need to mitigate that problem. So for that we need to add this one. Okay, so here I'm going to simulate this model. You have to check the result of the model. Okay, so you have to wait for a completion of simulation. So this is a result with the STATCOM. So here you see that, right, that speed deviation, right, speed deviation and transmitted, right, so that oscillation is reduced. Okay, after installing this PV STATCOM, right, So what happened, right? That that subsynchronous resonance, everything will be reduced in the system. Okay. So for that purpose only, here we are including that we are installing that PV STATCOM. Okay. So that will be take care of that subsynchronous resonance due to that series capacitor. And also here you will see that the different results. So grid voltage, current, and series capacitor voltage, right? And then this is uh, primary secondary voltage of the statcom, and then this is reactive power of the statcom, and then DC link voltage. And then here you will see that, right? So this is PV voltage and current of the PV array. And then here you will see that, so this is the tracking of reference current and actual current in this statcom, that means IQ and IQ reference. So this as a result you can see from that system with the PV statcom. So this is one of the method is used to for reducing the subsynchronous resonance in the series compensated transmission line. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.